together then, number one. So just focusing on what we're doing here, you can help me do it. So first of all, if we sketch this thing out, we need to have certain conventions in mind. The first convention to have in mind is that all angles are measured from this positive x-axis here in the anti-clockwise direction round here. So that would be a positive angle if I was measuring that way. If I really want to measure an angle this way, I can do, but then it will be a negative angle. So when I come up with my final angle for this 6 Newton force, if I was asked to find this, for example, then it would be round there like that. So resolve this force into its vertical and horizontal components. The other convention is that if I'm going to take forces acting that way, I'm going to call that positive, and that way I'm going to call positive. And that's up to you how you decide on the conventions. But that's what's been given to you. If I want to resolve into its vertical and horizontal components, what I'm after is what's the horizontal component of this force, what's its effect in the horizontal direction, which is this direction, and what's its effect in the vertical direction, which is this direction. So I'm after those values. So straight away, from the convention, that's going to be a negative vertical force and a negative horizontal force. So whatever answer I come up with, it's going to be a negative. To get the value, I imagine shifting this vertical component, this one here, from here, and shifting it over to here, so as I make a right angle triangle. So effectively, I've got a right angle triangle down here, and I'm after that side. So the vertical component is going to be the length of this side of the triangle here, and the horizontal component is going to be the length of that side of the triangle. So which ratios are involved? How would I find this side here? Right, it's to do with sine. So this horizontal component is going to equal the hypotenuse, which is 6 in this case, times the sine of the angle. That's the formula that I'm going to use. Yeah, thank you. Vertical, not horizontal. Well spotted. So that's going to equal, in this case, 6 times the sine of 40 degrees. So if we work that out, what do we get? So that gives 3.9 newtons to two significant figures. You might call it 4 to one significant figure. One thing missing from that, though, what's that? Minus, right, because it's going to the left negative. So the first one would be that, okay, negative 3.9 by convention. So similarly, what do we do to find the horizontal component of this force? Right, that would be the cosine times the cosine of theta, which is 6 times the cosine of 40 degrees. So comes out to be minus 4.6. A very common problem for you to have to do, resolve force into its vertical and horizontal components. And it's just a case of using those ratios, the sine and cosine ratios. So area A equals a half A plus B times H. Remember, we talked about in the first week that finding a half of something is the same as dividing it by 2. So I could write it as A plus B times H, all divided by 2. Or certainly think of it like that, even if I don't write it like that. So tips for rearranging formulae: if something's underneath divided, multiply through to get rid of it. So the first thing I would do here would be multiply through by 2 to get rid of the half effectively. So I'd have that 2A equals A plus B times H. So already it looks better because I've got rid of the denominator underneath on the right hand side. Remember what I'm after, which is B. So what might you do next? You could multiply out the bracket, or you could divide by H. In this case, either would work, but let's divide by H. Okay. If If I divide both sides by h, I get 2a over h equals a plus b. If I were to multiply out this bracket at this point, instead of dividing by h, if I were to multiply out the brackets, I'd have a h plus plus b h, and then I've got to worry about getting that h that's multiplied by the b. So that's why I would suggest divide by h in this case. So now you can see we're almost there. Look, remember after b, so what's the final step? Not divide, because it's added, take it away, right? Because what's the opposite of addition? Subtraction. So to get rid of the b has had a added, to get rid of the a, subtract a. So subtract a from both sides, 2a over h minus a equals b. And then I'd finally write it with the subject normally on the left-hand side. So b equals 2a over h minus a, and that would be my final formula. Would allow me to find b. A common sort of problem you might need to solve. I've tried to make these problems like you might get in an engineering situation. So, first of all, we've got the formula for the circle we need to remember, which is area of pi r squared. But I want the radius. I'm after the diameter, and the radius is half the diameter, so this formula allows me to find the radius. So once I've got the radius, I'm just going to double that to get the diameter. So that's my plan. So what I'm going to do now is to rearrange this formula. So I've got to get r on its own, so what do I do? Divide by pi first and then square root. So divide by pi, area over pi equals r squared. Okay, so r equals the square root of a over pi. So that's rearranged the formula for r. So we need to be able to rearrange the formula to be able to use it in the correct form. So therefore r equals the square root of a, which is 12.6, over pi. And I can do that in one hit on the calculator. So this gives us 2.0 to two significant figures. Well, we know the unit, 2.0 centimetres. So therefore, and this is a common symbol for therefore, those three dots, the diameter equals 4 centimetres to two significant figures. So to be able to do this problem, we need to be able to rearrange the formula to find r in this case. And we also need to remember the formula for the area of a circle. So formula, volume, area of the end. So it doesn't matter whether it's a square, cylinder, or anything which has got a uniform cross-sectional area all the way through. The volume is the area of the end. So in this case, that's pi r squared times the length, or times the height, whatever symbol you want to use. Pi r squared times the length. And last question, number 5. The charge across Q, across a capacitor, is given by this formula. Q equals CV. So you'll use this formula if you've not done already. Find the voltage across a 650 microfarad capacitor with a charge of 1.36 millicoulombs. So this question is about rearranging the formula, but also coping with these units, micro and milli. So I'll just leave you a second to have a go at it, see if you can do it, and then we'll look at it together. Okay, so for this question, the formula you're given needs to be rearranged for V. So if Q equals C times V, what do I do to get V on its own? Divide by C. So V equals Q divided by C. So rearrange the formula to get it in the right form. Now I would write down what I'm given. I'm given that C equals 650 microfarads, which is, what is micro? 10 to the minus 6. So I'd say that that's 650 times 10 to the minus 6 farads. The charge Q is 1.36 millicoulombs, which is 1.36 times 10 to the minus 3. So a good tip is to, if you're writing down information from a question or somewhere, some source, check it's in the right units, and if you're using these micro and milli, these prefixes, convert it to standard or engineering notation. Okay, so that's what you're going to plug into the calculator. So now the voltage V equals Q, which is 1.36 times 10 to the minus 3 divided by 650 times 10 to the minus 6. So now I get the calculator out and plug in to get the answer. Answer 2.1 volts to 2 significant figures. Appropriate number of significant figures because this is only to 2. We could have gone to 3 at a push, but as it comes out to about 2.09, then 2.1's appropriate. Those are the drill questions for the 4th of December. Okay? So if you can put them out of the way somewhere and make a note to have a look at them before the day, please.